everyone, and welcome back. It's the last simultaneous equation PowerPoint screencast video thingamajiggy, and it's here to celebrate everything you know about simultaneous equations, and we've tried to build it up nice and slow. So if you haven't watched simultaneous equations number 1, 2 and 3, please do not watch this because it will make absolutely no sense. But what are simultaneous equations? We've done this enough times. You don't even need to read that, but I will read it for you. Simultaneous equations are a pair of equations where there is more than one unknown value. We use the elimination method. We look for those twins, or we create those twins. There are the twins here, remember. We use those to eliminate one of the letters, and then we can work out the others. How do they make it harder, though? This is all about how they make it a little bit more difficult. Come on, Mr. Warren. They're not all this easy. And you're right, they're not all this easy. But the same skills that you've learned through the first 3 screencasts will be used in this screencast. But you've just got to look for how we might change things. And some people might be saying, I can only do the easy ones. Well, it's untrue. There are easy ones, and then there are ones that you can turn into easy ones, and we need to remember that. Most of maths, when they are a little bit more difficult, actually you've got to do 1 or 2 things before you make them really easy. So here's an example of something that's a little bit tougher, because we've got a negative in here, and means when we need to nullify this, we turn this into a minus, which means we need to turn this into a positive, which means we turn that. So that's the first way. They chuck in a negative, and therefore we need to know that we're not going to turn all of these into negatives. We just change the symbol on all of them. On the second one, we can see here we don't have twins. We've got twins here, but we don't have twins over here. So we have to create those twins by timesing this whole equation by 2, which will give us twins then, because on those ones we'll have 10y. And then last but not least, we have it where actually it's difficult to do both, because we can't easily make 5 into 6, and we can't easily make 2 into 3. So what we have to do on that occasion is we have to times both equations by a number, and we're going to go through those examples today. But trust me, you've got all the skills to already pay those bills. We're just going to go through them. So really, even if you were to try and give it a go before I do it, see what if you can try and come up with solutions to this before I do it, that would be a real step in the right direction for you, rather than just listening to me ramble on before you give it a go. So on this first one, if you want to pause the video, give it a go now, and then come back and see if you've got it right. That's fantastic. If you don't, I would highly recommend you giving it a go before you move on. But anyway, it's up to your confidence levels. On this first one, we can see that we've got our twins, but we need to make this a minus. If we make this a minus, then we make this a positive and this a minus. So let's do that. Let's do that now. Okay? So we're going to make that a minus, that a positive, and that a minus. And now it should be nice and easy, because what we've got is 4x, take away 4x, which is nothing. We've eliminated those. We've got 6y, take away 7y, and we've got, we've got 6y, add 7y, and we've got 46, take away 7. If we do all of those things, we'll end up with 13y equals 39. And if we divide both sides by 13, we'll end up with y equaling 3. And then you can very quickly put that back into one of those equations, and we're going to use the top one on this occasion, rewrite it with the y, rather than having a y, having 3, and then work through, and I'm sure that you would have got your answer, which is taking away 18 from both sides, which is 4x. I'm still going. I'm dividing by 4. We can see it's a little bit longer, but we end up with x equaling 7, y equaling 3. So you can see how they've made it a bit more difficult. They chuck in a different symbol. We'll just remember what you need to do in those occasions. Okay, so from this one, when we did this one in our last screencast, we had to multiply the bottom by 2 for a start. Okay, so we had to multiply the bottom by 2 for a start, which then turned it into 4x plus 10y equals 42. We then put on our top one. Now this one's a good one, because what we've got is we've got kind of our bigger equation at the bottom and our smaller equation at the top. So you need to turn this into a minus for a start, but by doing that, it makes it more difficult. So what we could do is actually turn this top one into a minus, all right? So that's what we're going to do on this occasion. We're going to turn these into a minus, and that's how they make it a little bit more difficult. Then we've got 4x, take away the 3x, which gives us x. And then we've got 10y, take away 10y, which gives us nothing. And then we've got 42, take away 39. If we had have done this, made all of these minuses, then we would have gone into negative numbers. And you still can do that, but it just makes it a bit more difficult. So then we've got x equaling 3, and then we're banging into it. We write out the equation, the smallest one, which I've taken from here. I'm going to take away the x and put in 3. I'm going to work my way through. So I've got 6 plus 5y equals 21. Take away 6 from both sides. We've got 5y equals 15. Divide both sides by 5, and we have y equals 3. So there we go. That's another example of how they make it a little bit more difficult. And then this is the last one, and we haven't covered this one yet. But on these ones, I can't multiply one of the equations to make twins, but I can multiply both. So that's what I'm going to do. I'm going to times the top equation by 3, and I will end up multiplying the bottom equation by 2. The reason why I've done that is so I can create 6 x's. So you can see now I've got 6x plus 18 equals 114. And then on the bottom, I'll have 6x minus 10y equals, hopefully it will be 2. We can see that there, can't we? So we've gone 2x times by 3 gives us 6x. We've got a 6y times by 3 gives us 18y. We've got 38 times by 3 gives us 114. We've got 3y times by 2, which gives us 6x. We've got minus 5y times by 2 minus 10y. And we've got 2 times by 1 gives us 2. And now we've got our twins. Now we can go about just treating it like a normal question. Now again, we're going to have to minus and plus. So you'll see that next, won't you? We're going to minus that one. Okay, so we eliminate it. But because we've changed that symbol, we're going to plus there and we're going to minus there. So we're going to end up with 28y equals 112, aren't we? Yeah, 28y equals 112. Divide both sides by 28. I'm whipping through this because you should know what I'm doing by now. And then we've got y equaling 4. Bang that back into the equation. I've picked the top one because it's a positive on this occasion rather than working with negatives. I don't like working with negatives. I'm sure you're the same. So I take away the y and input 4. So I end up with 2x plus 6 times 4 equals 38. What's 6 times 4? It's 24. So we've got 2x plus 24 equals 38. Then take away 24 from both sides. So we've got 2x equals 14. And then divide both sides by 2. And we end up with x equaling 7. Bang that over there and we are done. And that is it, okay? Now I know I've whipped through that, but I've whipped through it because you should already know how to do 90% of it. The hardest thing is we didn't know probably how to do this. Now we do. Now you can conquer all questions that you get given on the simultaneous equations when it comes to the elimination method. So here's the quiz question now. Can you do it? Yes, you can is the answer. Pause the video, give it a go, come back and see if you have got it correct. It's time to see how well you have done. This is the last of simultaneous equations. If you can do this question, you can do anything. So let's have a look and see. So I had to multiply both by 3 and 4 to get 12x's. I then had to change the symbols. I worked my way through. I ended up with y equaling 4, x equaling 7. You can see exactly what I've done to get all my answers there. Make sure that you've done the same. If you have, that's absolutely fantastic. Write a couple of revision cards or at least a revision card on this area. Make it a good one. Hopefully you've enjoyed this screencast. I have definitely enjoyed it. In fact, I enjoy all the screencasts unless it's really early in the morning or really late at night. And on this occasion, it's at lunchtime. And I love lunchtime. Until next time, it's been a real pleasure helping you with your maths.